Welcome to LabMinutes.com. In this video, we will look at three advanced security features on Cisco Nexus 1000V, and they are DHCP Snooping, Dynamic ARP Inspection, and IP Source Guard. These three features work the same way as other Cisco switches, with DAI and IP Source Guard relying on the dynamic database built from the DHCP Snooping or static entries. We will test these features with some of the security audit tools, and you will see how that helps you guard against these attacks. Here's our lab setup. So what we have here is pretty straightforward. We have a user VLAN 64 with the regular user on the LM Win7 test 1, and then we also have a malicious user running on the LM U121. We're going to be configuring DHCP Snooping, ARP Inspection, and IP Source Guard on the port profile VM VLAN 64 that will be applied to these two ports. So the first feature we're going to be looking at here is the DHCP Snooping. So let's get onto the VSM command line. If you do show feature, you see the DHCP Snooping by default is in disable state. So to enable that, you do feature DHCP. You can see that we are getting a little error message there that to enable the DHCP feature, you need an advanced license. And this is actually true, not just DHCP Snooping, but all three features we are looking at here. And in order to do that, unless you have a permanent license that you can install, we can enable a eval license. So let's do a show license usage. You see here, LAN service package is currently unused. So in order to enable the eval license for the advanced, you can do SVS switch edition. And here we have two options between essential and advanced. Essential is the default. So you can switch on advanced, and then you can do show license usage one more time. And you can see now the status has become in use with the expiration date 60 days after the date that you have VSM install. Okay, now if you do feature DHCP one more time, you can see that the switch now accepts the command without any error messages. Okay, so before we start on the configuration of DHCP Snooping, we just want to do a quick DHCP spoofing attack just to see what it looks like without the feature enable. So let me bring up the malicious user machine. Here we're going to use the tool called Ettercap. And what the tool does is going to spoof DHCP reply and acts as the man in the middle because you can manipulate things like default gateway. So we know that we are on a subnet, the IP of 1664, and just pick some high value of the IP and the subnet mask and the default gateway. So let's point the default gateway to itself, which is 64.32, and then enter. You can see right here now it's listening on Ethernet 0. And Ethernet 0 has the IP of 64.32, and we are currently running DHCP spoofing. So now if we go to our legitimate user machine and do IP config release, and then renew, you can see if I slide the windows to the left here, you can see there's a lot of activity in the background here on our tools. And right there, let me kind of stop this so we can scroll up and take a look in a second here. But as far as the client sees, it's retained the same IP, which is 64.34. But you can see how the default gateway changed to 64.32, which is pointing to the attacker machine. Okay, if you scroll up, you'll see previously it has a 64.1 as a default gateway. So what it means is basically all the traffic that needs to exit the subnet from this machine is now sent towards our tools here, our attacker tools. So we've successfully performed DHCP spoofing. And if we scroll up, let's see if we can find where all these started. So let's go all the way up. You can see right here, this is the UDP DHCP broadcast to port 67, which is the server. And then what this tool did, it replied with a fake offer right here, offering the IP. Oh, there's different IP than the one that was requested. And it's right here. Did it again, and this time it replied with the IP that the client requested, with itself being the default gateway. So this is without the DHCP Snooping turned on. So let's go back since we killed that already. Now let's go ahead and configure our DHCP Snooping. Since we have already enabled feature, we can go ahead and do the command IP DHCP Snooping enable globally, and then you do it per VLAN. We're dealing with VLAN 64, so 64, and let's see what other options we have. You got verify, so you want to verify, make sure the, let's see, MAC, basically the format of the packet looks correct with the MAC address, and the header matching the payload, and then we can also disable information option. Okay. Now we're gonna enable recovery if there's ever been a error disable port causing by DHCP snooping. As part of that is rate limit, so we want to make sure that gets recovered. Again, this is up to you. And we also want to specify the interval for the port to recover within 30 seconds. Now we need to enable DHCP snooping under the port profile. Actually, it's already enabled, but we just need to add additional command. Let's see what's available for us. So DHCP snooping, and this is the port profile we're working with VM VLAN 64. So we have two options. One is trust, and this is for the basically DHCP server facing port, and make sure our DHCP offer that's coming in is being trusted instead of dropping it. But since we're not dealing with the server facing port here, the other option that we can do is limit. So this is to rate limit the amount of DHCP packet that's coming into the port, and there shouldn't be too many of them, so let's say we want to restrict it at the 10 packet per second. Okay, in order for us to see syslog messages, we have a syslog running in the background, and we also want to enable the logging level for, let's see, DHCP snoop, and we want that to be level 7. So we're good to go. Let's run that tool one more time. Now that it's listening, we'll go back to our test machine and do another release renew, and then renew. Okay, you can see here this time it grabs the correct default gateway. All right, and at the same time, you can see as the log message right here, a new host has been added to the DHCP snooping binding table as well. Okay, you can see although our attacker tool is running in the background, did not really affect our client this time, and that's because the offer that's coming in from the attacker tools has been blocked by the DHCP snooping at the port. Okay, so going back to our switch, if we do show IP DHCP snooping, the binding, this is the binding table, you can see the MAC address, the IP mapping that was being learned as part of DHCP snooping process. Okay, so it's good to go. Let's cancel this. Before we move on, one last attack that we want to attempt to do is DHCP exhaustion or starvation attacks, where the attacker keeps sending lots of DHCP requests in attempt to exhaust the DHCP pool. So this time we're going to use the tool called Yoshiniya, and instead of command line, I'm going to do the graphical interface. It's very simple to use. So here there's a tab called DHCP. So this is basically the format of the DHCP packets that's going to get sent. And then all you need to do is just launch attack. And right here, sending discovery packet, I want to DOS it. So click OK. And right here you can see the number of DHCP packet that's being sent to the switch. Okay, let's cancel the attack and we'll see some results. So if you click through this output right here, you can see the source MAC address has changed for every single packet. And obviously, if you were to have like a port security turned on, this would have blocked it as well, because the switch will see multiple source MAC address off the same port. So that would have worked as well. But since we do not have port security turned on, let's see what we've got here. Before it, I believe it's still in error disable state. So let's make sure we capture something before it become turned on. Let's see. Looks like we missed that, so let's try that one more time. Launch attack. Okay. Cancel. Okay. Alright. So on the syslog messages here, you can see the port vEthernet 15 went down because of the error disable. And if you look a few lines above, it said has been error disabled due to excessive ingress rate 10 of DHCP packets. So obviously the number of packet that has entered the port is more than 10 per second, so that's why the port went to this error disable. You can see right here, if you do show interface status error disable, it said the port is currently down, and show interface VLAN 15 reviews are same thing. Okay, so that means our DHCP snooping is working as expected. Now let's move on to ARP inspection. Okay, so let's clear our syslog server in the back, and before we start with the configuration, again, we want to do a quick test attack. And this time what we're going to do is ARP poisoning. So we're going to have a attacker trying to spoof the ARP request, or ARP reply rather, and pretend that itself is a default gateway. Okay, so on our test machine, if you do, let's ping default gateway 64.1. Okay, it's pingable, ARP-A. See right here it is ends with C5. Okay, now back to our attacker's machine. Let's exit that. And we're going to use another tool called ARP Spoof. So ARP Spoof, and the IP you want to spoof is 172.16. Actually, before I do that, let me show the MAC address of this machine. So ifconfig, and the MAC address of ETH0 ends with 66. Okay, so go ARP spoof 172.16.64.1. So I say we want to spoof the default gateway. Let's see, right now it starts setting gratuitous ARP and pretend to be a 64.1 by putting its own MAC address in that ARP pack. If you go back to, let's see if we can try to delete the ARP entry. Let's see, there's a lot of those. So ARP-D. It looks like we need to be a admin for that, so let's try that. It's going to have to run as administrator. Close that, and then ARP-D. There you go. So try ARP-A again. Oh, that's trying to ping 172.16.64.1. Okay, although it's pingable, but let's look at the ARP. You can see right here where occasionally the ARP entry will become the MAC address of the attacker. Right here ends with 66. But at the same time, you can see it fights between the switch and the attacker. So it depends if you are able to catch the moment where right here again 66. Okay, so now let's turn on the ARP inspection on our switch. This command is IP ARP inspection, and first we do based on per VLAN, and we're dealing with VLAN 64. And then you also have an option to validate source MAC address, destination MAC address, as well as the IP inside the ARP payload. Okay, so we want to validate all those. And we also want to error disable the cause of ARP inspection. Okay, now on the port profile 64, we also want to enforce the limit. You can see here you can also do trust as well. And this is for when you have things like a static IPs configured on your host. And so that means the MAC to IP mapping would not show up on the dynamic DHCP snooping table. That's why you just wanted to trust the port. So basically, regardless of the ARP packets it's being seen on the port, the switch will automatically trust that. We're not going to do that here. Instead, we're just going to do limit and rate. And again, just similar to DHCP, you shouldn't be seeing too many ARP packets from a legitimate host, so we're just going to leave it at 10 packet. And then we're going to increase the locking level as well for ARP, 7. So it looks like our tool is still running. Let's make sure. There you go. And again, we can try to do this all day, and we should not see the MAC address of our attacker show up anymore, because that should be denied or rejected right at the switch port where the attacker machine is connected. And let's see if we go to the syslog server, you can see what kind of log message we have here. So right here, ARP frame denied due to DHCP snooping binding interface. So it's complaining about it cannot find the matching entries on the binding table with the MAC address of 90.9066, which is the MAC address of our attacker machine, and 64.1 since it's pretending to be something that it's not. Okay, so right here, that's where it gets dropped right on the switch port. Okay, so let's cancel that. So we just basically verified that our ARP inspection feature is working correctly. Okay, the last feature we're going to look at is IP source guard. Again, before we enable the feature, we want to do a quick test, attack test. So now the tool that we're going to use is called hping, where it allows you to basically craft the packet to whichever way you like, whether it's a source IP, destination IP, protocols. So what we're going to do here is trying to ping a switch 1, the upstream switch, using a spoofed source IP. Okay, so here's the switch 1. So we do debug IP ICMP so we can see all the ping that's being received by the switch. And now on the attacker machines, we can do hping 3 and specify ICMP as a protocol, and then the spoof source address. We just want to pick something like 1111, and that will go towards the host of 0.1, which is the loopback of the switch 1, and then you can enter. We're going to make sure the locking console is on as well. I'm not seeing anything happening. Let's see why. Let's make sure the port is good. Yep, port is up. Just try to do regular ping first. Make sure there's reachability. Okay, looks like the regular ping doesn't even work, so let's try to shut the port and see if that helps. Shut, no shut. Let's try it again with the regular ping. Oh, okay, I think I know what's going on here. So if you do show IP DHCP Snooping, bind, oh, you can see right here that the MAC address ends with 66, which belongs to our attacker host. It's not there yet. So that's why it's being rejected. You can see the lock as well. Since there's no entry, it's dropping it. Now let's see if we can force the VM to reobtain the IP by disconnecting the network interface, just to force the DHCP snooping to see the request and create the dynamic mapping. So right here, you can do disconnect, and then connect. And let's look at the binding table again. There you go. So 66 is now show up for the 64.32 IP. So if you're trying to ping, again, you can see the ping is working. And right there we get the ICMP debug output as well. So let's go back to hping command and ping with the spoof source IP. Now you can see right here the switch is trying to reply back to the spoof IP, which is 1111. Okay. So let's stop that. Now let's go back to the switch. And again, if you're not familiar with IP source guard, it basically stops a main host from using the IP address as a source address that doesn't really belong to it by basically checking it back with the DHCP snooping table. Okay, so now we have to turn on IP source guard. This command is IP source binding, and you can do filter. Actually, let me step back here. Question mark. You can do a static mapping if you have a machine with a static IPs. Then you have to create a static mapping right here with the IP address, and then you map it with the, just to show you, with the MAC address and then VLAN and the interface. So basically you create a static entry just like the one that's already in the snooping, DHCP snooping table. So we'll turn on filter mode, and we want to filter based on both IP and MAC address. Okay, and now you have to turn it on at the port level. So if you go under the port profile, go VM VLAN 64 with the command IP verify source question mark, and turn on the IP source guard. And you can see right here it said, the description said turn on the source guard for the VLAN where the snooping is enabled. So that is turned on. You can see a little log message that just came in that said IP source guard is enabled on interface via Ethernet 15. Okay, so let's clear that out. So we have a clean page here, and let's go back to our attacker machine and launch the ping with the spoof IP address again. Okay, so now while that is running, you can see we no longer have any output on the debug since the switch is no longer receiving the packet, hence it does not do any echo reply. At the same time, we have a log message that show up, but actually this is related to the ARP inspection. Okay, but you can see the switch one no longer receives the spoofed ICMP with a spoof source IP. Okay, so these are some of the advanced features or security features you might want to consider enable in your user environment, especially if you run VDI. And this is to protect your network from whether it's intentional attack or machine that might have been infected and start attacking the network even without the user knowledge. But again, just keep in mind that all these three features are part of the advanced license in the Nexus 1KV. Okay, so that wraps up our video on Cisco Nexus 1000V on DHCP Snooping, Dynamic ARP Inspection, and IP Source Guard. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.